Hello students, and welcome to the final video of lesson 5.3. In this video, we're going to be looking at using our theorems when we're going to be given a table problem. So let's get started. So I've got my table here, and we know that f and g are differentiable for all the real values. G is also strictly increasing, so it's also going to always be going up, up, up. The table above gives those. So we have this table given at specific x values 1, 2, 3, and 4, and we have a function h, and that's f of g of x minus 6. So we want to find the equation of the tangent line drawn to the graph of h when x equals 3. So let's think about the things that we need whenever we need a tangent line equation. First, we need the point of tangency. In order to find the point of tangency here, we need h of 3. So f of g of 3 minus 6. And I'm going to follow the table. So g of 3 here is going to be 4. So now I'm going to write down over there f of 4 minus 6. And f of 4, I'm going to be following it right there. And then that is going to be negative 1. So I get negative 1 minus 6, which is going to be negative 7. All right, so now I have my point of tangency. Well, what's the other thing I need is I need the slope of the tangent line. In order to get the slope of the tangent line, I need the derivative of h. So let's find h prime of x real quick. And that is going to be f prime of g of x times g prime of x. And then the derivative of the constant negative 6 is going to be 0. So that's just an application of the chain rule. And we want to find, okay, what is h prime of 3 going to be? So f prime of g of 3 times g prime of 3. All right, so g of 3 is going to be 4. So I'm going to have f prime of 4 down there. And then g prime of 3 is going to be 2. All right, and then f prime of 4 is going to be 3. So I get 3 times 2, which gets me 6. So now I have enough information to go ahead and write the equation of the tangent lines. So then that's going to be y plus 7 equals 6 times x minus 3. Have I answered the question? Yes. I've done all that specific work here and I got the equation of the tangent line that I needed. So then you know that you are finished with that problem. All right, so let's go ahead and look at our next problem. We want to find the rate of change of h on the interval from 1 to 3. So essentially just the average rate of change. So let's do this. We're going to want h of 1 minus h of 3 over 1 minus 3. So h of 1 is going to be f of g of 1 minus 6. And then we're going to subtract h of 3. And we've already done the work for h of 3 because we got negative 7 right there over negative 2. So h of 1 comes out to be 9 minus 6, which is 3 minus that negative 7 over negative 2. So 3 plus 7 is 10 over negative 2. So that's going to be negative 5. And that's the average rate of change on the interval from 1 to 3. All right, so now we want to explain why there must be a value of r on the interval from 1 to 3 such that h of r equals negative 2. So notice here that we're looking at an interval. We're looking across the value negative 2, but we're not looking where that derivative is. So that's kind of tipping my hand that I'm thinking about the intermediate value theorem. So what do I need to do for the intermediate value theorem? Well, first I'm going to want, okay, what is h of 1 and h of 3? Well, h of 1 equals 3 and h of 3 equals negative 7. The other thing that I need to state from the intermediate value theorem is that the function is continuous. Because if the function is not continuous, we don't guarantee that we cross every value in between that 3 and negative 7 there. But because f of x and g of x are differentiable, that means h of x must be continuous. Since h of 3 is less than the h of r value that we want, which is less than h of 1, the intermediate value theorem guarantees a value r on 1 to 3 such that h of r equals negative 2. We could spend a lot of time searching to see if there is an exact value of r that we'd be able to find, but that's not what this question is asking us to do. It's just saying, does it exist? And sometimes just answering yes or no to that question is a very important first step in mathematics and science. So now let's kind of look at this final question. Explain why there is a value of c for the interval 1 to 3 such that h prime of c equals -5. So as I'm looking at this, from 1 to 3, I'm looking at an interval and I'm looking for that derivative equal to -5, so an exact value. So that's kind of tipping me off to the mean value theorem. All right, what I also want you to notice is that in part B, we already did part of the mean value theorem where we found the average rate of change on 1 to 3, and we noticed that it's equal to -5. So as I come down here and I'm looking at this question, from part B, the average rate of change of h of x on 0 to 3 is -5, so I don't need to do that work again. Since f of x and g of x are differentiable, h of x is continuous and differentiable on 0 to 3. Therefore, the mean value theorem is going to be guaranteeing a value c on 1 to 3 such that h prime of c equals -5. Again, we're not trying to specify what that value is, we're just trying to say that one exists. All right, so now that we have answered that question, you really want to spend the time to think about, okay, what are the specifics that I need whenever I'm using these theorems? They are going to come up in free response questions, and you're going to need to say IVT, mean value theorem, Rolle's theorem, whatever you're using, you're going to want to specify them. You're also going to want to check those boxes and make sure everything gets concluded properly. If you're not quite sure how any of these values get calculated, any parts of these problems, or if you need help with anything, please reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.